Welcome back, guys. Welcome back. We're still gonna doing our derivation. We are still going to apply. I hope you still remember this from our previous video where we did this example of 7 1 over 3 plus 7 over 3, where we need to add this fraction. By adding this fraction, the denominator is the same, so we just take one denominator and we add our exponent by 1 plus 7. So this is the same as this, so we're going to apply the same thing here, but this one is in this form. So it starts from this form, so we to this form. So how do we do it? We just say 4 into x, where there's x squared, and plus, changing this root is just going to be x into 1 over 2 into x squared. Now this is the same as this. Applying this, I hope you understand and I hope you see it. When we are adding fractions of the same denominator, we take one denominator, then we add our exponent. So here we have one denominator, we take one denominator, which is this one, we add our numerator. Numerator is this one, where this one is this and this one is this. I hope you still understand. Then from here, just going to apply. We're still simplifying, so it's still f at x. So from here, use the exponent rules. So it's just going to be x into 1 minus 2, taking this to up phezulu, change the sign, plus x into 1 over 2, lowering phezulu, which is going to be minus 2, and 4 into x, this is just going to be minus 1, and plus x 1 over 2 minus 1, it's just going to be negative 3 over 2, still f at x, still f at x. Now we can derive, if we're deriving f prime, don't forget f prime. F at x is not the same as f prime, so deriving this just going to be this to this, it's just going to be negative 4 minus 1 minus 1 minus 2, then this times this is negative 3 over 2, negative 3 over 2 minus 1 is negative 5 over 2. We don't leave our answer in the negative exponent, so it's negative 4 all over x. Then this is 2 because we are upon 1 with denominator 2, then it's negative 3 over 2, no I upon just going to be x into 5 over 2. I hope you understand that one. I hope you do. Then I'm just going to do another one where we have 4x squared minus 9 all over 2x minus 3. I hope you see here. Now it's different, a little bit different. We can't apply this one because now we have two factors that are separated by this negative sign. So now what we need to do here, we need to apply what we have learned from grade 10. We can factorize this thing. What type of factorization is this? It's different of two squares. So factorizing this, open two brackets, square root of 4 is just 2, and 2 square root of x squared, it's x, and x square root of 9, which is 3, and 3, and then positive, negative, all over 2x minus 3, and then this cancels this, and then we are left by ubani 2x plus bani plus 3. This is just our f at x. We just simplified it. Then from here we can now deriving by putting f prime of x. Deriving this is just 2. Why 2? Because this one gonna times this, just gonna make it 2, and then no one that one minus 1 is 0. Anything raised by 0, it's 1. The derivative of a constant is 0. So we have this. Just gonna squeeze the last one, which I think is also very important. Just f at x into x squared minus 2x minus 3 into 6 minus 2x. Also here, what we need to do is to apply our factorization, which is our trinomial here, phezulu. We need to factorize. I hope you still know how to factorize the factors x and x. The factors of that is just 3 and 1, where we have negative 3 and we have positive 1 all over. Now here we have a common factor here. Our common factor is 2, because 2 yangena ku 2 ngena ku 1, and also 2 yangena ku 6 ngena ka 2 ka 3, because 2 for 6 ka 3. So we're just going to take our common factor, but what is important here, we're just going to take a negative 2. Why negative 2? Because we're just going to have left by x minus 3, because if terms are low, just going to give us this, and also times in this and this is just going to give us positive 6, where this thing now is the same as this. I hope you understand. This now contains this. We are left with x minus 1 all over or negative 2. I hope you get that one. I hope you do. Then from there, now this we can apply this form by just saying x into negative 2 plus 1 into negative 2. This thing is just the same as 1 over 2 negative 1 over 2x, and this times this is just negative 1 over 2. Still f at x, still f at x, still f at x. Then from here we can just derive, which is f prime of x, which is just negative 1 over 2, and that is negative 1 over 2, because this is a constant. It's going to be 0 a derivative here corner, so we're just going to be left by this 1 here times in this, which is just negative 1 over 2, and then 1 minus 1 is just 0. Anything times anything raised to 0 is just 1. So this is our derivation. Important part here, it's here. It's very important, this one. I hope you do understand it. Thank you so much, guys, for watching. Keep supporting the channel.